Any questions on any of the homework assignments? Yeah. All right, guys. So what we're looking at today is exponential growth and exponential decay, or exponential functions. Now, we're going to define an exponential function as y is equal to a times b to the x. A times b to the x. If it's going to be considered a growth function if b is greater than 1. And it's going to be considered a decay function if it is between 0 and 1. But both of these are considered exponential functions, growth or decay. So anytime we have a function in this form here, where b is either greater than 1 or between 0 and 1, it's considered an exponential. And the other big thing with exponential is that they grow at an increased rate. As we go from one number to the next, the values of y are going to increase at an exponential rate. Now, we're going to look at these tables here and determine whether it is a linear function or an exponential function. Now, linear functions increase at the same rate. Values of x and y will increase at the same amount. So if we look at letter A, so the difference between each of the x values, so the difference between 0 and 1 is what? So what would the difference between 0 and 1 be? One. What's the difference between 1 and 2? 2 and 3. Okay. So here, the change in x and the change in y is the same. It is constant, yes? So if we have a constant change in the x and the y, it is considered to be linear. Okay, so the first one's linear because the change in x and the change in y is the exact same. Now let's look at letter B. So what's the change in x from 0 to 1 to 2 to 3? Well, the change is 1. But we're adding 1 to each x number because if we add 1 to 0, we get 1. If we add 1 to 1, we get 2. If we add 1 to 2, we get 3. Now what's the difference? So let's see here. So the difference between 8 and 4 is, because 8 minus 4 is 4. How about 16 minus 8? (32 minus 16). So this here, the difference in x is increasing by 1, yes? But the increase in y, well, that's 4, 8, 16. It's increasing at a faster and faster rate, yes? So this here is what we would call an exponential function. And it would be considered an exponential growth because the numbers are getting bigger. The values of y are getting bigger. I added an S. Exponential. I didn't, yeah. EXPONENTIAL. Yep. All right, we're going to look at these next two. So we looked at two of these tables. We'll look at two more. So looking at the x values, what is the difference between 0 and 2? That would be 2. What's the difference between 2 and 4? 4 and 6. Well, 2, we're adding 2 each time, yes? How about the difference between 2 and 4? 4 and 6. 6 and 8. So this here would be linear because our change in x and change in y are the same. We have this constant change. Let's look at B. Well, this would be 1, 1, and 1 because we just keep adding 1. How about the difference between 1 and 3? 3 and 9. 9 and 27. So this here is increasing at a faster and faster rate. So this here would be exponential because we're increasing this faster and faster. All right, let's look at some more of these. We'll look at these last two and then we'll move on to the next type. One, 1, and 1. Yes, do we agree? Difference between 0 and 1 is 1. Difference between 1 and 2 is 1. Difference between 2 and 3 is 1. What is the difference between 8 and 4? And it would be what? Because we are going backwards, we're going down. How about 4 and 2? So would this be linear or exponential? Keep wanting to spell it with an S. It would be exponential because we're decreasing at this rate. So exponential functions can increase or they can decrease at this rate here. How about this one here? What's the difference between -4 and 0? It would be 4 because the numbers are going up. How about 0 and 4? 4 and 8? Difference between 1 and 0? And it would be 0 and -1. Because we're still going. And -1. What would this be? It would be linear. Because the change in x is a constant, we're adding 4, and the y values are all being subtracted by 1. So they would be this here. This would be linear. Okay. Evaluate each function for the given value of x. So we're given this here. Y is equal to this is the function that we're given. Yes? And we want to know what is the value of y when x is what? 3. So what would we do? We would replace x with 3. Plug it in. Type it into the calculator, see what you get. If you haven't typed it in yet, go on and type it in. Make sure we all agree. We all get negative 250. Okay, let's try the next one. Y equals 3 times 0.5 to the x. X is equal to negative 2. So we would plug negative 2 in for x. Type this in, see what you get. $12. Does everybody get the same answer? Got this right here. Oh. 12. Yep. And that is it. Any questions on this here? Or do we feel good with these here? We like these? We like ones that we can just type into the calculator and gives us our answer? All right. Okay. Now, we're going to go over this. I want to look through this here a little bit, graphing. Y equals ax to the b when b is greater than 1, and y is equal to ab to the x when 0 is less than b is less than 1. Now, if we graph these here, we look at these here, and really we find points. And we go about picking 5 overall points and graphing them. But I'm not going to worry too much about this here for us. What I do want to look at is kind of determining whether a function is exponential or not. Determine whether each equation represents an exponential function, and kind of explain why. Is this an exponential function? Well, what is our exponential function? A times b to the x. Would we consider this here 4 times 7 to the x? Would we consider this to be an exponential function? Is it in the form a times b to the x? Well, yes. What would be the value of a? A would be 4, b would be 7. So yes, this is in exponential form because it follows the form y equals a times b to the x. So this here is yes. How about y equals 5x? Is this an exponential function? What do y'all think? Possibly. So where is the variable x for exponential? It's up in the exponent, yes? Is x in the exponent? No. So is this exponential? No. This is actually going to be linear, because when we have 5x, we don't have x to a power, it's going to be considered linear. It is a linear function. Okay, let's look at another one. There. How about this one here? Is this an exponential function? What do we think? Yes or no? So does it come in the form a times b to the x? Do we have b to the x, a number to a variable? Well, the x is to the third power, isn't it? But the variable should be where? In the exponent, yes? Is the variable in the exponent? No. So this here is no. This here is actually a polynomial function. So that doesn't work. All right, guys. How about this one here? Y equals -2 to the x. It is in the form a times b to the x, yes? But there's one stipulation. B has to be greater than 0. They're going to throw this in every now and then. So this here is not exponential. It is in the form a times b to the x. It is in that exponential form, but it cannot be negative. Okay? So let's look at this one here. Is this exponential? Only changed one little thing. I dropped the parentheses. So this one's no. How about this one? The 2 would become positive, so the negative is outside, yes? So this one here would be yes. There's another way we can look at this is really negative to the x. So the b value is positive. So this one works. Because it does come in the form a times b to the x. And that's it.